Hi, class. We're going to look at exercises 2.6, excuse me, through 2.11, dealing with coming up with that cost formula, that mixed cost formula. In this case, the cost that we're referring to exhibits both a variable behavior or characteristics as well. There is a fixed cost component to it as well. So that's why we have to come up with the cost formula. As a reminder, the whole reason why we come up with that cost formula is to determine those components, the variable and the fixed, and that way we can estimate going forward based off of the expected activity level related to that cost. The end result, the deliverable, if you will, that cost formula C equals Vx plus F, where C is the cost at the activity level, V is the variable cost per unit, X is the independent variable, that's the activity level based off of whatever the driver is, and then F, that is your total fixed cost. This formula, remember, mirrors the formula for the line, the equation of a line, the y equals mx plus b, with y being the y-axis amount, m being the slope of the line, in our case, the variable cost per unit, x being the same, and then b being the y-intercept, in our case, the F being the total fixed cost, is also the y-intercept. At an activity level of 0, we still incur this minimum amount of cost, which is the fixed cost. So let's take a look at the problem. All of these exercises are based off of the question stem here in 2.6. So just as a reminder, Cinco Corp is a manufacturing company. They produce a wide range of products. They are able to sell well, but don't have a great handle on their costs. And this is, very common for lots of businesses that I deal with. Because of this, they're not able to plan accordingly and also not meeting their internal profit goals. To get a better handle on things, Cinco Corp controller Steve Brule has put you in charge to perform cost analysis. One cost they're having a particular hard time with projecting is maintenance costs of their machinery and equipment. Based on your understanding of cost behavior and the data that is available, you decide to use the high-low method to analyze the maintenance costs. Below is the data set you have assembled. So there, and I know it's a little bit wonky as it's showing on my screen, but we have the data for a 12-month period. So we have obviously each month. We have the total maintenance costs for each month. And then we also have the driver, or the estimated, or the one that we feel has the most correlation with the cost is the amount of maintenance hours. We're going to be able to use this entire data set to determine what is the equation of the line based off of this historical performance, and then we can use that equation of the line, or that mixed cost formula, to estimate costs at any activity level related to maintenance hours. So the first thing we have to do here in exercise 2.6, the first thing you do in any mixed cost formula process when you're given a data set, you have to pick the high and the low. So I've recreated the data set here, and these files will all be available on your course site. So just you can have this at your disposal here. But I've recreated the data set here a little bit clearer. And the first thing we have to do again is to determine which is the high month and which is the low month. Now I've picked July as the high and December as the low. And reminder, how do we go about doing that? It is based off of the independent variable. So you have to ask yourself, does maintenance costs, is it based off of the amount of, is maintenance hours reliant on the amount of maintenance cost? Or is maintenance cost reliant on the amount of maintenance hours? And obviously, that is the scenario there. The more hours we incur, the more cost we incur. It's not the other way around. That tells me that maintenance cost is going to be the dependent variable. Maintenance hours is going to be the independent variable. So as I'm picking the high and low, I simply look to maintenance hours, and I'm going to pick the high month. So based off of my data set here, the high month is 102 hours, which correlates with the month of July. So that's going to be my high month. My low value for the year is going to be 40 hours, which occurs in December. So that's going to be my low month. So those are my two data points here. 102 hours results in $1,800 in maintenance costs in July. 40 hours results in $1,076 in the month of December. The next thing we're going to do in exercise 2.7, not to get too far ahead here. The next thing we do, now that we have the high and the low picked, we want to pick out or determine the slope of our equation, our cost equation. For our purposes, slope we refer to as variable costs per unit. How do I calculate variable cost per unit? Well, that's simply the difference in cost between the high and the low month divided by the difference in hours, in this case, between the high and the low month. If I want to, maybe I can make it a little bit clearer here. For July, my cost was $1,800. For December, my cost is $1,076. So the difference is 724 hours, or dollars, excuse me. That number is going to be divided by the difference in hours, or the independent variable used in July versus December. So in July, we used 102 hours, less the amount that we used in December, which was 40 hours. 62 hours is the difference. Those two numbers I'm going to divide to get my variable cost per unit, my slope. And just to confirm it there, I get, and again, assuming I round to the nearest cent, I get a variable cost per unit of $11.68. So what does that number mean? Because it's one thing to know how to calculate a number, which obviously I want you to know, but you also have to know, what does it mean? What does it explain? What this number is saying is that based off of this historical data set, these 12 months that we have at our disposal, on average, every maintenance hour that we incurred variable costs related to maintenance of $11.68. That's what that's saying there. So why that's important, because going forward, as we estimate, every hour that we estimate we're going to use, we're going to estimate a variable maintenance cost of $11.68. Moving on now to exercise 2.8. I just kind of want to focus here. They want us now to come up with the fixed costs. We have the variable costs per unit. Now we want to determine the fixed costs. This is our formula, remember, C equals Vx plus F. So of the four variables, what do we have? What is known at this point in time? When you're doing this, you're going to plug back either the high point or the low point. It does not matter which one you do. I like to do the high point for whatever reason. If you want to plug in the low point, that's fine. But let's say we are plugging in July. We are plugging in $1,800 of maintenance costs at 102 maintenance hours. Well, where does that go into this formula? Well, C is the cost. We're not estimating it in this instance. We know what the cost was in July. It was $1,800. So I'm going to plug in $1,800 for C. My V, we just calculated it in exercise 2.7, was $11.68. So I'm going to plug that in for V. My X, that's the independent variable. So at a cost of $1,800, our activity was 102 maintenance hours. So that's what I'm going to plug in for X. F, that's what I'm solving for. I have one equation, I have one unknown, therefore I can use this to solve for total fixed costs. This formula here is just C equals Vx plus F with everything plugged in that I know. So instead of C, I have $1,800 equals, instead of V, I have 1168 times X, but instead of X, I have 102 hours, and we're still solving for F. So all I do at this point is then I go through my multiplication of the variable cost times the number of hours. So I get $1,800 equals 1191.36 plus F. Now to isolate for F, I'm going to subtract 1191 from both sides. My final results, and again, you can see the formulas here. Total fixed cost is $608.64. So again, what does that number actually mean? Because again, one thing to calculate it, it's another thing to actually know what it means. That means that if I'm at activity level of 0, for whatever reason, I will still incur maintenance costs per month of $608.64. and 64 cents. And that could be anything. That could be indirect labor. Maybe there's some additional materials that I have to buy. There's certain maintenance costs that I incur no matter what. Whatever the case is, at activity level 0, my y-intercept, or in our case, our total fixed costs, I will incur $608.64. So now reviewing where we're at this point, we have our variable cost of $11.68 per maintenance hour. We now have our total fixed cost of $608.64. We can now state or write what is our mixed cost formula. So what we have done is we have taken this raw data here and we have converted it using the high-low method into this cost formula. So our cost formula that we're going to use is C equals 11.68x plus $608.64. And why is this so important? Because now I can use this mixed cost formula to estimate maintenance costs going forward, assuming, of course, that historical performance is going to remain accurate, that this data set is truly reflective of future maintenance costs to be incurred. So how can I use that formula? Well, in exercise 210, they ask us to estimate the maintenance costs at 55 maintenance hours. So I have my cost formula. I'm going to plug in my knowns. So I know my V, it's 1168. My X is what they ask for in the question, which is 55 hours. My F is the fixed cost we just calculated, the $608.64. So I do the math there, 1168 times 55 plus $608.64 gets me an estimated maintenance cost of $1,251.04. So again, the assumption here is that assuming historical cost performance is accurate, this formula is accurate, then if I plug in 55 hours into this formula, I'm going to estimate maintenance costs of around $1,251.